So I want to welcome everybody to this GPUG event. It is an evening of microservices and Docker with special guest Dave Redfurn. This is our October meetup. I was coming down the stairs getting ready, and I was thinking, Jesus, October, maybe we've done like a spooky, kind of like GPUG theme. And then I realized it actually is kind of spooky, right? I know that I'm afraid of using Docker, and then so hopefully, hopefully Dave is able to quell my fears about that tonight. So let's talk about our agenda. So I'm going to do the welcome, which I am doing right now, and then we're going to do some introductions. We're going to have a word from our sponsors this time, and then we'll jump on with the show. All right, so let's talk introductions. I am Colin DiCarlo. I am your master of ceremonies tonight. Today we've got Dave Redfurn. Dave, you can see he's an IT gopher. Sounds kind of funny. We found out where he was from earlier in the evening, but maybe at the end of the night, for the people that weren't here, you can guess as well. He's got over 20 years messing with web apps, and over the last 4 years, he's been dealing with Docker and microservices. So that's Dave. He's going to be talking for us tonight. All right, so talk about our sponsors here. So for the longest time, Vehicle has been a sponsor of the GPUG. They, at the time that we were meeting together, they were giving us the space and the food and all that sort of stuff. It was really great, keeping the lights on for us. Now they just give me the time to organize this every month. So I want to say a special thank you to Vehicle for making this happen. We also have a new sponsor this month, and that is Givelify. To talk a little bit about Givelify, I'd like to welcome Peter Meth. Peter, why don't you give us a little word from our sponsor?
Hey, I'm Peter, and I've been working at Givelify for a little over 2 years now. And so I mentioned to them about all the awesomeness that goes on in the GPUG, and they were falling all over themselves to sponsor. What is Givelify doing sponsoring a PHP meetup in Guelphish, Waterloo, Kitchener, Acton, wherever we are. So Givelify, we have a mobile app. That's our main product is a mobile app, but it's for giving, and it's primarily used by churches, but also by nonprofits as well. And we have our tagline is the place where our mission is to be the place where all giving happens. Unfortunately, that was only means in the United States because it's a US based company, and they don't have service anywhere outside of the United States. So one day they will hopefully move into Canada, and that will be a good day. Givelify is a company where giving happens. And we want to help everyone here become better givers. And we also want to be, friends to the PHP community. I've been for many years, and now I'm selling them on the benefits of that. So take it away.
Awesome. Thanks again, Peter. And thanks again also to Givelify for sponsoring tonight. Givelify gave us the Zoom conference that we're actually using tonight. So thanks again. All right. Let's go on with the show, I believe. So I'm going to hand things off. I'm going to stop sharing now, hand things off to Dave. And Dave is going to talk to us all about microservices and Docker. All right. Over to you, man.
Hello, everybody. As Colin said, my name's Dave Redfurn. I'm PHP developer by trade. Been doing this for quite a number of years now. And the last 4 of those have been working across 2 different companies that have both ended up on a microservices architecture. So what I want to do is just to work through how I have approached this from my experiences of this, because there are so many ways of implementing this, and I've struggled through and struggled with my colleagues to get something together that will work repeatedly and reliably. And it's one of these things where I've been thinking of doing this for, doing a presentation and talk on this for a while and just, never got around to it. So it's like, why not? Might as well get on with it. So the main goal tonight is to go through the tool chain that I use that works for me, and the pros and cons of that aspect. So we're going to first just revisit all the microservices, make sure we're on the same page, then look at some of the reasons why you might want to or not, and then how you can decide to split up your application or your project into microservices if you decide that it's a good fit for you. And then we'll dive into how I do things, along with some of the tools which I've built to help me and my colleagues tame the madness that ends up being the case. And we're going to be doing a fair amount of live coding. So it's like, I hope it's going to work. I have been testing this out, so all things being equal, we should be good. All right, so the end result of this little session, we should have a running basic environment that we could then develop further microservices in. So that's going to be our databases, logging, even a little bit of Kibana in there, and a rudimentary authentication service. So just a basic API that gives us users and accounts, and then be able to just manage it in a sane way. But to kick off with, what is a microservice? And being the good coder that I am, I immediately went to Martin Fowler's website and then ripped out whatever he said. So in short, the microservice architectural style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. These services are built around business capabilities and independently deployable by fully automated deployment machinery. And it goes on with a bunch of other stuff. So essentially, it's just, it takes a part of your application and makes it a service. So you can hit it as an endpoint, you can query it. So instead of getting your user model, which eloquent model, which then talks to the database, you implement something else which talks to an API, and you end up with the same result. It tends to be used a lot, especially a lot, because it works really nicely if you're using domain-driven design to build your product. Although you don't have to, it just really helps. So the next part of this is the crux of it, is whether or not you really want to go down this road, because there's obviously trade-offs to everything. If you're using a monolithic application like what we're all probably used to, your Laravel, Symfony, Cake, whatever it happens to be, or you're using Python or Node, you write your code, it's all in one place, you deploy it to the server. Great, you can just stick it on a droplet or whatever you want to do. It's really straightforward, really easy. But with the microservices, now you don't no longer have that. You're going to have any number of them, which could be in any number of languages with any number of different storage mediums. Yeah, so it could be Postgres, MySQL, Redis, flat files, no storage at all, because maybe all you've got is just something which does processing and then hands it off to something else. It's entirely up to the problems that you're trying to solve. And when you start approaching from that point of view, microservices only really make sense if you have got a particularly complicated business problem that you're trying to tackle. I mean, if all you're wanting to do is, write a blog and have comments, this is the worst possible way of doing it. That problem's been solved. Pick a solution which you like and then go nuts with it. But if you've got something that's rather more involved, so I will use my own experiences here. So my first one was a commercial real estate company that had to scrape, because we didn't have data feeds for most of our data, third-party websites, some of which were under agreement and some weren't, but, strictly speaking, it's whatever. But that data then had to be processed and then normalized, and then turned into something useful, and then formatted so that we could actually search on it, and then linked with other data sets, and then turned into yet more data derived from linking of those data sets. And when you start looking at that kind of problem, you can start to see where, well, the scraping is its own process. Like, you wouldn't want to include that in the main project because it's extremely specific. And that was all done in Python, actually, using Beautiful Soup, I think it was. And then the main part of the code was like the API side of things was in PHP, and we had multiple services, mostly using Postgres because it's geospatial data. And each one of those was then, we could build it and deploy it however we wanted, with the trade-off being that instead of one project, we were managing, I think we got up to 60 repos, so not huge, but, you know, getting to the point of, yeah, this is a bit uncomfortable, and GitHub's interface for dealing with like that number of repositories is not ideal. It would be really nice if they allowed you to group things together into, like, you know, folders of projects or by, you know, project type. So it is that trade-off. You know, other things which you should think about and consider is, do you have the in-house knowledge to do this? You know, it's a lot of extra work. So you need to know that you've got the people available to manage your infrastructure, to help when things go wrong. Obviously, it's going to cost more in hosting by virtue of there being more things. You know, generally speaking, you're going to have for every microservice a specific data source, which means multiple database instances. So you're not going to share a database. There will be, or you might share a database server and then have multiple databases within it to cut costs or whatever, but ultimately you're going to have multiple database servers, probably. And if you want replication and failover, yes, definitely. So you are going to have trade-offs on the various aspects of it. And obviously, I mean, the overarching one is, whatever is then your front end application is going to be making a lot of API calls, which is going to be over HTTP. So, as we all know from our own experiences, HTTP is slow versus, you know, a binary connection to MySQL or Postgres or whatever, or Redis. So you've got to really think about it and plan it in mind with what your business needs are. However, with that said, if you do have microservices, each one becomes its own independent thing that you can just manage isolated from everything else. Your contract is your API. So you can spec and build your API and then slowly implement it, and everyone else can just use your mocked up JSON or XML, or whatever it is that you happen to use, as the contract between them and you. And so long as your API produces that output, everything looks great. And then you can deploy the stuff as you want. You can version things independently. You can, you know, manage. So if you've got one service which needs a lot more resource than another, you can scale that one up independently of everything else. So it is, you know, there are pros and cons. Fortunately, in my last place, the commercial real estate, we actually had dedicated DevOps people. So they managed all of the infrastructure for us, which is great because I hate doing servers. So it's definitely one of the things I would say is that microservices really does benefit most if you have a dedicated DevOps team. So yeah, there are certain tricks that you don't have to start with. In fact, I would actually recommend that you never start building microservices right from the get-go. It's better to start just to get a grip of what it is that you're trying to solve and build it just as using whatever tech that you want. That commercial real estate project started off as a Laravel application, actually. Way back, it was as its very first commit running in Vagrant. So it wasn't even Dockerized at the very beginning. It was all running under Homestead. And then over time, it just grew. And then as we looked at and started to understand what we wanted it to do, we were able to split it out. So an important part of it is to make sure that you structure your code in a way that it can be split. So you have to think in terms of independent chunks of your functionality that can be grouped together. And the easiest way of doing that is rather than having, you know, using the Laravel example of app models, you have app, whatever the thing is, users, or listing or order or invoice, then models. So you namespace your code is the very easiest thing to do. And then you make sure that the data sources are all pointing at different databases. And that's the most basic way of starting down that road if you think you're going to need it, because at that point it's really easy to just back out and not do it. So how would you decide to split this up an application? Well, as I already mentioned, microservices really came about out of the work that the domain-driven design people came up with. It really came out of Eric Evans and Vernon Vaughan and Fowler, because essentially a microservice maps one-to-one with a domain-driven design aggregate root. That is essentially the very definition of a microservice. So if you know what an aggregate root is, that is what manages the state of your domain. It's your entry point into it, and it takes care of the transaction boundary, just glossing over it at a very, very high level. But it just means really that if you need to make a user or modify the user, you go to the user aggregate root and you say, change my name or change the name to whatever it happens to be, or allow access to a resource. So you use the natural language of your company. So this is where you really need to think carefully about what it is that you're doing, and you need to really understand your domain before you can start splitting things up, which is why I always say start with monolithic service, which is both of the projects I've worked on, both started off as monolithic services that have been converted over time into microservices. Now, strictly speaking, if you were to take like every possible aggregate root and have it as its own independent service, it gets really awful really quick. If you just think of the example of a user belongs to an account and can be granted access to groups, well, the account's an aggregate root, the user's an aggregate root because it has its own state. It might be dependent on the account, but it has its own state. So you can have a user service, an account service. If you've got authentication service, at that point, you start subdividing, and you kind of get services that overflow. And ultimately, that's just really bad to work with, because now you can't get all of the user information without making or querying multiple APIs. And yes, there's what is the Facebook thing that came up with GraphQL as like a response to that kind of thing, to be able to queries for specific bits of information. There's not really a great solution. So what I do is group those things logically together. So I have an accounts service or a user service which has all of the users and the accounts, so you can group it all together. And the way I tend to think about it is, how do I need to access this information? Like, do I need to be able to cross-reference users with accounts? Do I need to be able to do reporting queries of like number of users within an account, or are there looking at orders and invoices? What type of reporting queries will I need to run against that before getting into like a reporting service itself? And then if the data is correlated, quite strongly, it's tied together, even if conceptually they're different, I tend to bundle them into the same service, but still taking care not to intermingle it too much. You want to try and keep it consistent, because querying is not the same as writing it. So, if you keep that in mind, and that querying is a completely separate task to what you're trying to assist, then things become a lot easier. And then obviously, if you do split down to fine grain, you've got way more HTTP calls, just more lag, more to go wrong, more debug, more services to have to monitor, hosting costs, blah blah blah. The upshot of that, though, is that you can always merge them back together. provided that you've taken sufficient steps to namespace, and like your URLs actually have prefixes, and it's not just straight into whatever it is you're trying to modify. So say, for example, you've got a user's service. If you've got user.app/v1 and then an ID, that's really hard to move. Whereas if you've got v1/users/its ID, so you've namespaced everything to do with the user under the user's segment of the URL. That's actually what I've done a couple of times already in my current project, where we had these two services that were only really used by two other components. One was literally a list of rights organizations. I think there was 23 records. It was its entire own full-blown microservice for 23 records, used almost entirely by one other service. So I moved it into the other service and then got rid of it. And nothing was impacted. All I had to do was change one value of an environment variable to point to the new URL for it. So it went from prose to songs. That was it. Everything continued to work. Another one was a channels service, which there's a list of TV channels, several thousand records, but really only needed by two other services. And we needed to do a lot of cross-linking on that one. It was just better to have it next to where it was needed. And actually, the benefit of that is now paying dividends, because it means we can do cleverer things as well. We can do more roll-ups with the data that we're needing to query. So that's kind of like the intro part of this. So how do I do this? Now, if you go online and you read about microservices and how to do this, you're going to find a general consensus is that you Docker everything, like stick it in Kubernetes, and in your project you have your Docker compose file, and you stick everything in there. Your application, your web service, your databases, Redis, maybe there's some Rabbit or whatever other queue you're using, maybe Beanstalk, and then I don't know what else would be in there. I can't think now. Maybe some other stuff that you throw around. You end up with each service has all of these things in it. But when you start to actually work that way, which is how I did things to begin with, you reach a point where, well, now you need to restore a database. So you need to write your tooling to restore the database. And yeah, you could extract it into a library, and then you could stick it into private packages or Composer, and you could try and script it, and you could do this and you could do that. But fundamentally, really, all you really want in your microservice is your application, and then anything that's specific to the application, which for me tends to be the app and Redis. That's the one thing I do is I keep a specific Redis instance for each of my apps, keep them segregated. In production, you probably use a couple of different Redis instances depending on what it is that you're doing, or how much caching you need. So the very first thing that I like to do before even writing a single line of code is I like to talk to the people about what it is they're trying to do. What is it they want out of whatever it is I'm trying to build for them? Whether it's a report, or it's an invoice, or it's a monthly sales figure, or whatever it has, I need to understand what it is they want out of it. Because if I don't get that, if I don't know what they want out, I'm just going to write garbage. So I find it's really important to understand and to be able to talk with the people you're working with in a language that they understand, so that there's no ambiguity and you don't get crossed wires. And that when you talk about an invoice, you actually mean the actual invoice that the salespeople are using, and not actually the delivery sheet that your dispatchers are interested in. You might be similar, but they're different concepts. So it's really important to know and to be able to have colleagues around you that can answer your questions, and just ask. any question, it doesn't matter what it is. If you don't understand, just ask away. And that's one of the things which really helped in certainly my current role, where the company works with recorded music and the performance rights and royalties associated with that music, which is horrifically complicated. Not because it has to be, but because it's been made that way. And without them and asking, just why is it this? Why is it that? Why don't you do this? What is the reason for this particular way? Why do we have to deal with these people and why can't we do that? It's important to know that, because at some point, in your code, you are actually going to put these ideas and these limitations physically into what you're writing. So you need to understand why you are doing that. And that's when I really do like DDD in the way that it's structured and how it encourages this communication. And that's really the single biggest factor in any of this. And then from those discussions, you can then start to tease out what the big concepts are, and then how those might, how those relates to each other, and how they could be written. And throughout all of this, I'm not even caring about how I'm going to store it. To be frank, usually it's going to be SQL because that's what I'm most familiar with, and for the majority of the time, I end up having to do the initial server setup, as much as I dislike that. So I'm most familiar with, an SQL data store. So I'm fairly risk averse when it comes to the tech stack, because I want stuff to work, and I want it to work first time repeatedly. So if I don't have someone with the knowledge to do it for me, or to share that knowledge, to train me on it, I tend to backpedal a bit and just go with what I know is familiar ground. So that's going to be Postgres or MySQL for the most part. If I had someone that knew Mongo or Rethink or Cassandra or whatever, then I'd probably look at using those for that particular use case at that time. Now, where I tend to differ from a lot of people that talk about microservices is that I view a microservice very much as a domain service. So it's a concept within our domain. So that means no one outside of the company should have access to this thing for any reason. So I don't care about auth. I ignore it. I don't deal with auth. I don't think about JWT or API access or access controls or rate limiting or anything like that. That's another problem to be solved further down the line, because the chances are you don't even need to solve it. In both cases, we always, but my recent experiences, both times we've thought about having an external API, and not once have we built one. So why go to all the hassle and the effort of having to build auth into every single microservice, which becomes a massive, complicated affair. So the consequence of that is that if you've got an SPA, it's not going to be talking directly to the domain services. It's going to have to go through a proxy service that will make the request on its behalf. So yes, there is that trade-off. However, it does mean that it's vastly easier to actually lock down your environment, because you can use firewalling, you can use NATs, you can, I can't think of the word now, virtual LAN, you can VLAN it, segregate off your databases, your APIs, and then from your external services that are actually exposed to the public, you can put in multiple layers of protection far more easily than if you have to start exposing these things. And it does make life a lot easier, in my experience. Again, though, if you have the technical capacity on your team for actually having everything open-ended and you can secure it and you're confident in that, then by all means go for that. But sooner or later, you have to figure out how you protect those APIs from anyone being able to do replay attacks or being able to steal the keys out of your front end applications. So like with everything, it's trade-offs. Okay, what comes next? Oh, yes. Big benefit when doing anything with microservices is CQRS. So command, query, responsibility, separation, segregation, whichever word you want to use. And out of that, command bus, query bus, which I know Laravel did start to introduce in, I think it was Laravel 5 or 5.1, but they've kind of shied away from it. But for microservices, this really does make a big difference. If you're going to write a change, dispatch a command, write a command handler, and then encapsulate the code that makes the change in that handler. Because now if you want to change it, let's say you go from your user's persistent to a database, and you just go to an API, change your command handler, everything else stays the same. And the same with queries. Actually, I came into a query bus quite a bit later. I was using the command bus already, and then I was using, because I like doctrine, I like entity mapping, so that's what I was using as my primary like ORM layer. But I was never particularly happy with how I was then using doctrine to query for the information out of in my APIs. It always felt clunky to me. So I've made all of this effort to ensure that when you make a change, like you want to change the property listing, and you want to add in a bunch of different offers and floor sizes and special features. All of this was wonderfully taken care of in the transaction boundary. It was all the code was set up to model this and make it nice and easy and simple, and so you couldn't make a bad change to that data. Everything was securely typed. You couldn't put bad values in. But then to read it, I'd have to then go and break all of that code essentially to be able to get the stuff out. And it never felt like it was a particularly good solution to me until I actually went and implemented a query bus, and then got rid of doctrine from that side at all and just did like essentially rolled my own. And that made life so much easier. It really did. Yes, you get more classes, but the classes themselves are small and extremely focused, and you can test them. You can see what dependencies are in your query handler. You know what the output is. You can completely test the whole thing. And as an upshot, if you then need to dispatch that same query or that command on your CLI without any HTTP input, as long as you can format the command object with the stuff that it wants, everything works. It makes life really straightforward and gives you a lot of reusable code. So the largest part of though that was the biggest problem that I ran into with this was the local devs environment. Because if you get 10 developers in a room and tell them to set up their dev environment, you will get 10 different environments. And then someone who's being really awkward and actually has 2 separate environments, and so you've got 11, which is not necessarily great when you want to then get everyone running with the same application and it all running the same way. Yes, Docker helps to some extent, but there are issues with that. One of the things which always bugged me was constantly having to edit my host file because I've added a new service and now I can't reference it. So over time, I've dug into a lot of it and figured out, probably everyone already knew about, DNS mask. But I've been able to figure out and plug all of that together into a more consistent dev experience, which has been a large part of what I've spent the last probably 3 years. It started at my previous place, and certainly my current one, I spent a lot more time actually investing into my toolchain. And out of that, I've built a couple of tools to help with sort of managing the setup of those things. Because while Docker is great, and you can use Docker Compose, it's not so great when you're dealing with a lot of separate things, which we'll get into in a little bit when we start actually writing, well, more like plugging in into these libraries. So the primary one, which is what is going to be the focus really tonight, is I call it my project manager. So practically all of my open source code, I use the name Somnambulist. It's the name of a song by Brian Trento. Also, apparently, it means it's a sleepwalker. I didn't know that, but there you go. That's the reason for Somnambulist. So it's all on Somnambulist-tech on GitHub. I put most of my stuff up there. There's a few things which are still in my my personal repo because I haven't been able to move them, or there wasn't a need to move it. But you're welcome to poke around, and pull requests are always greatly appreciated. So I wanted to, or what was important was solving this problem of making sure that the devs could get things up and running. Because the biggest problem I had with Docker and the multiple services was some services have dependencies. Like, for example, in my commercial real estate one, there was a search service which was dependent on the listing service, but they were both dependent on, I can't remember which other one it was. It was dependent on something else. So to be able to do anything with search, you needed to have a bunch of other infrastructure up and running in place. But you can't do that with Docker, at least I'm aware of. And so I found various ways of doing it, but it ultimately it came down to, like, did you read the README file? No. All right. Okay. Read the README file and then start. And it's like one of those, you get that itch and you just got to scratch it. And so I was like, there's got to be a way of fixing this, And at first it was a bunch of bash scripts that try and like figure things out, but it never felt particularly great, and my bash ability is very limited, and it rapidly became way too complicated. So I was like, I know PHP, I'm familiar with PHP. What damage can we do with PHP today? And so this is where I came up with Project Manager, which started out very simply and has now expanded into what I find is a useful tool that I use every day in my day-to-day job. So this thing, it's all it really is just a glorified front end across a particular way of working. It's literally a config file in YAML that tells the thing where it can find services or libraries. In this case, a service is a Docker service, so something which runs in Docker, and a library is just a piece of shared code. Typically, for our purposes, it's something that's going to be hosted in private packages or in packages. Just library code that you're going to reuse, and it just provides a nice little CLI environment to be able to see what is where, what is installed, and so that you can then share that with the people that you're working with. So it's reasonably configurable. The way I like to work is I have in my home user, so Dave, projects. I like a projects folder, and then each major project has its own folder name. And then I have everything's in that, which sometimes it's better to then split down into like services and libraries, but structure the internal of that however the hell you want. This is what works for me. Everything is text-based. If you don't like it, just delete it. It doesn't override anything in your environment. And at this point, here we go. Hopefully, this is clear and legible for everyone. The project manager itself, you can manage it through Brew, so you can just Brew install it. The instructions are on the site itself. It's pretty straightforward. I already have it in. And then when you run it, it's all your usual stuff. the usual range of commands. So you got stuff working with libraries in the project. So the service we already touched on, libraries we already touched on. The project is just the top level folder that groups all of those services together. So for me, I normally use the company name that I'm currently working with. So if I list out what I've currently got, see that there's a Docker, there's Madagascar, which is my domain. I have some stuff under that, which I haven't touched in ages. Melos, which is my current company stuff, and then Somnambulist, which is all of my stuff. And then it gives us some other useful information, such as where it currently is located, how many libraries there are, and number of services. So just a top level overview. And from this, we can then make sure that if your colleagues download and run it, you can actually share this information. So each one of these projects can have its own Git repo to just hold its configuration, which obviously you should keep private. You should not have that public at all, because you could put in keys and stuff that you want to share, preferably encrypted. But you can do that. And the primary configuration for it, it is just a YAML file. Everything is YAML files. And you can edit and tweak this stuff to your heart's content. So where I tend to differ quite a lot, I think I've mentioned this before with microservices, is how I go about building the infrastructure for the microservices. So I don't like duplicating myself. Like, all good developers are really lazy. The best of us, we like to automate the stuff which we hate doing. So one of the things I really, really hate doing is anything involving database backup and restore. So for my microservices, what I like to do is centralize that into a single project, which I just call data services or data service or whatever. And that's where I will have my different Postgres instances or MySQL or whatever it happens to be for all of my services. And the reason for that is because now when I want to restore all of my data, because I take snapshots from production to use as my dev environment, because fortunately we do not have any sensitive information in our system, so I can do that. If I was having to deal with business that had like PPI, protected information, then obviously you'd probably want to run that through Cqrs first before actually using it in a dev environment. But being able to restore everything in one go for all of your services is a lot more convenient than, did I restore it for that database? I don't remember. Did I CD to that project and then did I run that? So yes, you can share the code for all of that, but I just don't like doing it. But if you guys are into that kind of thing, or you've got a minion that likes to deal with server related stuff, then all the power to you. So what I like to do, and what I have done, is I have a template data service that I've pre-configured with the stuff which I think is useful for the types of projects that I build. So that is a syslog instance, RabbitMQ for sending messages, a load balancer, which in this case is Trafic, which if you're not familiar with, is actually really cool. You can do lots and lots of really cool stuff with it. It's really, really awesome if you're using Kubernetes and Docker in production as well. So we'll see that shortly. A local DNS for doing resolution, because I don't like editing my host file. And then if I have databases, I'll do my databases. Like I say, this is one place for all the usual backup and restore tools. And this also makes it for a nice place to put in documentation about the structure of the services, or to document what ports you're currently using for which service, that kind of thing. Although what we'll see is that you can actually get that from the running services using SPM once we get that far. But let's go ahead and first we're going to make sure I get this right. We're going to call it GPUG. We're going to create a GPUG. And we don't have a Git repo yet. Yes, it's fine. And it asks for the Docker Compose name. So what we're going to do is we're going to prefix all of our Docker related stuff with GPUG. And that's just so we can essentially grep for it through the Docker output. If you've ever tried to deal with lots and lots of Docker containers and you don't use specific names, then you will know what kind of hell you get. And that's it. It's now created our little project, so we can then switch over to it. And I know it's already created it, so we have an empty GPUG folder, and you see it's in my project. So the first step now is we're going to services create, and we're going to call it data service. Yes. And we've got a bunch of different templates, which it's all code which I've made available. So you'll see there's Laravel and Symfony projects, which all they do is just compose or create project create for Laravel or Symfony. And then logging is, we'll use that one in a little bit. Events is just a really basic little mini Symfony app to just record event information into an events database. It's really lightweight. And an API and an app are just slight variations, which are all both Symfony, but you can customize this. Like if you could create your own project which pre-configures your environment for your use case for your company. I've done that for Melos. So there's a couple of templates for Melos. So we can just run this and it will pre-build with, because we use private packages, so it'll preset the keys for that. And it will make sure that the domain names are all set up properly and that all the binding is correct for Melos's use case. But here we want the data. And I know that the primary container is one called proxy, which we'll see in a minute. And hey, there we go. Now we have a data service. Yay! So what we can then do is we can now open the data service, and I've got it configured to use PHP Storm. This doesn't always work though, because for whatever reason, PHP Storm's CLI helper sometimes just dies and it just won't open. But I've tried to make it so that you can just do this, it's kind of useful to be able to be anywhere in your file system and go, oh, actually I need to be in the user service right now. So you can just go SPM open. And that also will give you a list of things as well. So you can do, it'll list out what you've got. But first, what we need to do,
hey,
so
Dave,
you have to make a, yeah.
Sorry to interrupt. We just have one question right now, and it was going over I believe it was regarding the project templates that we're talking about. And so the question was, have you thought about making these project decorators so you can pick and choose and combine decorators over base templates?
Nope. Largely because that's not been my use case.
Mm-hmm.
I'm not quite sure how that would work though, because it's like, what would you want to layer on top of what? Like, there'd have to be restrictions in that. Like this one can be decorated by these things, whereas I tend to like the Laravel one. Like I said, all it does under the hood is call composer create project Laravel/Laravel. I think it is. So it's just like syntactic sugar at that point. It's more to be able to keep your team on the same page.
Yeah.
So these things only really make sense when you're dealing with a number of people who, when you say to someone, oh, go and make a service to go and implement whatever feature it is. And they go, how do I do that? And the first thing they do is they copy one of your previous ones, which in my experience tends to be they copy it badly.
I know exactly what you mean. Yeah.
Yeah. And then you're forever finding bugs and such. Whereas this allows you to, if you, in the case of like if your own, you might have a particular set of things which you always need installed in your project. So why not just make that as a skeleton project? If you actually look on my GitHub, you'll see that these are all, there's like a data service skeleton. There's the API, web API skeleton. They're just standard projects. And you can do whatever you want. It's all versions, it's all in Git. And then SPM can either compose or install if you've registered it with Packagist, or you can just reference the Git repo and it will check it out, remove the .git folder, and then just initialize a new repo for you. And then you just go from there. And then it's bare bones. I mean, you could do things like you could get as convoluted as you want. So you could add in like bash scripts to do like pre-complete, or use a PHP script and ask questions as like the first run kind of thing. I haven't bothered that far, except in asterisk in my library support side of things. There is a special set of code in SPM that allows you to define two PHP files which can ask questions, and it will just do a search and replace through code. But you can then tailor that to do whatever the hell you want. So those projects, those templates, you keep within your project configuration. Right now, I only have one of those. I use for an API client library for Melos. And what that allows you to do is it just has all of the basic layouts and files for making API requests to an endpoint. And you still have to customize it and stick everything in, but it gets rid of the setup side of things.
Yeah, I think that's actually sort of along the lines of what Hossein was asking the question, what he was getting about layering an API over certain types of projects and whatnot. So yeah, I think that's along the same lines that he was thinking about. So that's kind of interesting.
All right, so right now, so the first things we need to do is we've got to customize a bit of this, and I'm sure that everyone can think of better ways of doing this, but so I'm saying a project domain is fairly self-explanatory. And then in the Docker Compose, so this is you see this is why it's templated. So these are the definitions for Postgres databases for two of my the events and accounts templates. We then got the proxy configuration, which is right here, which don't need to do anything with, and we don't have to do anything else in there or in there. But we do want to go and I'm still getting used to my keyboard, so I recently changed from Natural 4000 to the Microsoft Natural, and some of the keys are in a different place, and I'm still not quite comfortable with it. So I use a lot of named volumes and like named network segments. So for those that aren't overly familiar with Docker, when you use it, the notion of a network is a first-class citizen. It's actually a thing in Docker. So it can have a name, and you can sort out its routing. You can then define what its capabilities are and that kind of thing. And if you don't specify it, it will just make a name, like in the usual Ubuntu style, or whatever the words are, galloping gazelle or whatever it is. But for our purposes, we want to be able to actually target this later on. And you can define multiple networks. I've seen quite a few people like to do things like they will create a database network and then an app network, or a front-end network. And then they will bind their containers to specific networks. So, for example, their SPA only has access to the app, but it can't see the database. So there is that segregation. I personally don't go in for that because I like a simple life. In production, you may want to do something like that, but that's a problem for somebody else as far as I'm concerned. So I think that's all we have to do in there. So I must remember that in DNS, I do need to change this because I always forget this. And this is really important. Okay, so the final part of this is we need to generate up an SSL certificate because thanks to Google, anything on .dev requires an SSL cert, so you can't access it without it. So I got fed up of trying to figure this out, so I wrote a bash script as part of the data services thing, so you can just run bin gen SSL, and there's actually a rec.cnf file in the proxy folder, which just defines a bunch of pre-built stuff, and then the bash script just reads the environment file and pulls out the domain name and then sticks it in there. But you can customize that however the hell you want. So the final part of that, you'll see here that it's also outputted this extra command because by default, this is a self-signed certificate. So if we don't install it into our system keychain, it ain't going to work. And we'll just get like, this is what is it? Unverified address, and it won't get access. So we're just going to go and there we go. So we can verify to ourselves that that actually worked. If you use Linux, I have no idea what the equivalent is. You're on your own. But you'll see under system, you'll see there's GPUG dev, and it's set up to be always trusted. Yay. Obviously, this is for dev only. I do not recommend doing this under any normal circumstances. You should probably consider using Let's Encrypt or an actual certificate if your business or your company wants that kind of thing. But for this demo, it's fine. For Melos, I actually have a shell script that calls out to DigitalOcean, and it actually generates a Let's Encrypt certificate using certbot. But that one's kind of scary in that you have to have a admin key in a text file on your local machine to be able to actually call the API and to actually change the record on the DNS entry, which is a bit scary. I don't like that. Again, this is why I like to make DevOps type stuff somebody else's problem. All right, so registered, okay. Customize, edit DNS mask. Okie dokie. So that should be everything. And at this point, we can either go and use DC up, or we can just go SPM start, and what it will do is just build it. I just did it with debugging, so you can see that all it's actually doing under the hood is calling out to Docker Compose up, which I have aliased. So if you ever see me do DC up, that's just Docker Compose. I've just aliased it because I hate typing Docker Compose. And now we'll see that, yes, we have a bunch of stuff running, and a bunch of things that have been made available to us. Yay, go us. Or if we use SPM status, we get a much nicer view of what's currently going on. So what we can see is we've got a DNS container, which is actually registered as dns.gpug.dev. A bunch of ports are available. We've then got the proxy service. So if you remember, or probably forgotten already, but when we set up the this service, we were asked for a specific container name for the primary service, and I entered proxy. So that actually was the name, so I already knew ahead of time of that proxy container in our Docker Compose file. So you see here, so we've got Rabbit and DNS, and then we have proxy. right there. So it's just that name. And all it is it's just that SPM knows what to look for in the Docker output, so it can map it. That's all it is, and then it just processes the ports in here and turns it into something which I think is a lot prettier. So if let's see if this is going to work. Oh, that won't work just yet because there's one step missing. And I've said that I really dislike messing with my host file. So what I like to do, and what's actually been set up here is this DNS service is DNS mask. And what you can do with Mac OS, and I think you can do something similar with Linux. Windows users, you're completely on your own. I've got no idea. But you can create, you do have to make it. It's not there by default, but this folder called Resolver in etc. And what this allows you to do, and you'll see, here's one I wrote earlier from my testing. It allows you to set DNS lookup entries that OS X will use. So it's really straightforward. The format is the domain, whatever it happens to be, the name server, which would be in most cases 127.0.0.1, the port, which is really, really, really important, especially for Mac OS, and then the search order, which is just how much of a priority it is, with lower numbers being less priority. So I don't even know if that actually has an impact on Mac OS. I've never seen it actually make the slightest bit of difference, to be honest. But the port is really important because Mac OS essentially doesn't like anything other than the default, which I think it's 43 for DNS. Someone can correct me if I'm wrong there. Or 1034, which is the other port that's reserved. Now, you're supposed to be able to use any port that you want, but Mac OS will not use it. I have not found no way for it to work. Even sticking like a dot on the port on the name server, it's just never. I've never got it to work. But this, it does. Incidentally, if you're using Brew on Mac OS, PHP through Brew, by default, the version of curl that it's got won't go through OS X's default DNS resolution. It'll just ignore all this, so you may end up having to enter some host entries anyway. The other little gotcha with this as well is that this folder and these files are only reread when the file name changes, not the content. So if you copy a file, the act of copying it. So say, for example, we just do cp gpug to gpug.com, which I'm pretty sure I'm spelling correctly because, gpug.com. That will then immediately take the content of gpug.com, which is exactly the same as gpug.dev, and go, yay, everything's great. And if you edit it, none of those changes will appear. So what you then have to do is move it to a new thing and then move it back to where you actually want it to trigger it to reload. And then, so you got to watch out for that one. Don't ask me why it's set that way. I have no idea. That's just the way it is. And then I think it's scutil --DNS. And we can see that, yes, there we go. GPUG is set up to resolve for us. And now, oh my God, is it going to work? The moment of truth. Let's see, is this going to work? GPUG.dev. Oh no. I thought I had this working. No, why are you not working? Okay. It says it can't. Let's see if it's. Nope, it's actually going to sulk a lot. All right. And if all else fails, what's going on here? Let me understand. No, that's fine. Oh, I know what's happened. Yes. This is because earlier today, when I was messing around with this, I ran through all of these things, and I was doing all of the testing, and then I didn't actually delete the certificate. So
always that certificate, eh? Just every single time.
yeah. So let's try that again. Okay. I think it's supposed to overwrite it, but I think that sometimes it doesn't. And then this almost certainly means that it now won't work. I think I have to quit Safari and restart Safari. Let's start GPUG. No, why is it not? Well, it's not giving a very helpful. Did I spell it correctly in?
Dave, is there anything that we might be able to do to help? You?
At the moment, no.
All right.
I do have one other way I can do this. In that, under my login, I can go to here, and then it is config. Yeah, it's just this is the fun and games of doing the setup. I did have this working. So I'll just try it this way around. I can use that one. Trust, always trust. Yes. Okay, let's see. Try Opera, seems like gives slightly better error messages. Cert authority invalid. No, why are you doing this to me? Oh, God damn it. I know what it is. All right, so remember me saying that I did a lot of testing of this to get things up and running and to make sure everything was going to flow nicely. The one thing I forgot to do is delete the GPUG images that I had pre-compiled. So Docker, when you run a Docker compose file or a Docker process, it creates an image or multiple layers which make up the image, and then that image then turns into a container. And then once you shut down the container, like what I've just done here, the container is discarded, it's gone. And then when you start a new one, it takes the image and pulls it back. But it's really, 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 really aggressive with its cache. In fact, if I do a DC build by default, you will see that using cache pretty much everywhere. If I then do no cache, it will now actually go ahead and redo it. So what it hadn't done was copy the correct certificate file into the proxy volume. So there we go. So that now, if all else fails, Docker system prune -a --volumes, delete everything.
It's a good thing you did lots of testing to make sure this went smoothly.
Yes.
Zing.
Yeah. Yeah. So let's see. Is this going to be any better? Yay! Okay.
Moment of truth.
So that's the DNS server, but I'm just going to. So there's a HT access, HT password on that one. But we'll pull up the proxy, and this is the Trafic dashboard.
Wow.
Yay! We get there in the end.
That's terrific.
Yeah. So Trafic is a load balancer, but it has built-in support for Docker. So we can actually read your Docker sock file and then auto-configure your services and things that you want to expose, and you can automatically have stuff mapped. So you saw there, I didn't edit my host file at all. And yeah, I've gone to proxy, I've gone to DNS. And if I was to go and open up, I can go to rabbitmq.gpug.dev. Hopefully you're back. Rabbit. Oh, it might just be Rabbit, not Rabbit MQ. There we go. We've got Rabbit, and it's just guest by default. So and there we go. We're into Rabbit. No messing around with host files. It's just all done. And in Trafic, if we look under HTTP, we'll see that we've got TLS is already enabled. We've got the various containers and their host names. And yay, woohoo! There we go. Half the battle. So you can see, even with all of my practicing, still really easy to screw up.
So where is it getting these host names from?
So these host names, I said that I was just going to use gpug.dev, but they're actually set on, switch back to PHP Storm. And forgive me if I'm going too fast. I have a habit of sometimes of getting ahead of myself. It's actually configured through these labels right here. So Trafic, the current version of Trafic is quite a bit different to the first version. So some of you may have played with Trafic 1, which is a lot easier to get working than Trafic 2. But it does all of its configuration through labels. So it has no impact on anything else to do with Docker. So if you want to stop using it, it's fine. It's just labels. It's just a piece of text. It doesn't affect Docker or anything else in any way. So the important ones first is we have to turn on support. We want Trafic to listen to this thing, and then you have to set up the rules for how Trafic should route traffic to this thing. So the first one is this router's proxy, which is the name of this service. So you see that's proxy. So this name must be the container name. So if you change this to Trafic, then these three entries here must reflect whatever this name is. And that still catches me out. I will forget to change it and then be wondering why it doesn't work. And then here I'm just using a bit of n variable foo that you just then you could just write in. Obviously, you would actually hard code it to whatever you wanted instead of using that. I just did this because I was being really lazy because I can. And then finally, yes, we want TLS. So if you're using .dev, it's got to be served over SSL. You can't access it without. If you're trying to use a browser, if you're using curl or whatever, it's fine. Doesn't matter. And then this load balancer port. So this is slightly different. So HTTP services. So again, the name of the container, and this is the port of your container that should be used that for this service. So in the case of Trafic, that's 8080. So it means that any request, so like port 80 or whatever, will be forwarded to 8080 in the container. So on the DNS side of things, again, it's using 8080. I tend to use 8080 for the internal services, but that could also be 5380 if we wanted, if that's what was exposed by that container. And Rabbit forwards to 15672, which is the standard default port for the Rabbit MQ management console. So if you wanted to add an app server, you would on your Nginx, you would say you'd add labels for it, and then point to whatever the Nginx port is, which we can actually do right now. I believe that's what comes next.
So Dave, we just have another
yes?
question here. Can you generate this file from a simpler config file so you don't have to rewrite the name multiple times in the interest of dry?
Which config file? Docker compose file?
I'm going to have to wait for an answer on that one.
Yes, Docker compose.
Peter says, yeah, Docker compose.
I just read the message. I didn't say.
I could but it's a law of diminishing returns, because this is not like this is just a suggestion. Like, you might not want to use Rabbit. You might not want to use the DNS or the proxy, whatever. If you're not, then why were you using this project anyway? I don't know. This is just a suitable set of defaults. So the intention is that you clone this. It's now yours. So if you don't like something in it, delete it.
We're actually referring to the Trafic configuration.
Oh, these things. I have no idea. This is what it has to be done as. There's no way, as far as I'm aware. I suppose you could write a bash script to process this stuff, but then you've got to, because of this dependency here of the container name to the router and the service, you're going to have to read the Docker compose. I suppose you could do a simplified version. But then it's like, what do you do when the port's different? Yeah, I mean, all I do is I copy and paste this between my projects.
Yep.
Because I don't remember it. And once you've written it, it doesn't change unless you change the host name or the ports, which is very rare. I mean, yeah, you could. But to me, it's not been much of an issue. And I don't think there's a benefit to adding another config type to be pre-processed to generate. I mean, you can, yeah, sure.
Yeah. I'm kind of thinking right now of what do they talk about? Like anything's possible with adding another level of indirection or something like that, which is kind of like what we're talking about at this point. I think I might be with you.
Okay, so I do have other things, but I think I'll skip just adding Kibana because it takes ages to set that one. Well, ages to download it because Elastic and Kibana are enormous images. But I do have a pre-configured logging service if you want to get. It's only the really, really basic Kibana setup. It does nothing special because it actually is really quite involved to get Kibana up and running like really nicely. But that template is pre-built because in the list of services here, you see there's a syslog service, and my logging service is pre-configured to listen to the syslog files. So it'll stream the files into Kibana. So you get centralized logging if you use that. But we'll skip that and we'll go straight on to auth. Because ultimately, I mean, most authentication systems, users, possibly accounts, end up looking 99% the same. And after writing the same thing, I think it was the Melos, this was the fifth time, something like that. I just went, screw it, here's a pre-built one as a base, make it open source. It's built the way I like to build things, like right now. It might change in 6 months. It's a little Symfony app. And it's got tests and all the rest of it. But it's just intended as like this data service. It's just intended to kickstart, so you just don't have, so you've got less to do. It's like, use Laravel with auth, is it, on the Laravel command, like in the scaffolding, and it will pre-build you the login and reset password and like, hey, welcome to Laravel, you're logged in or whatever. It's that, but in a microservice. So what we'll do is services create, and we're going to call it accounts service, and yes, and we're going to use the accounts template. And in this one, it's going to be accounts app will be our container name. And there we go. All right, so now we have the accounts service, and there's a whole bunch of files already there. And once again, we can SPM open and service. Although I could have just done PHP storm dot. No, do not sync. And so this is for those of you that aren't overly familiar with Symfony, this is just a really basic Symfony 5 application. This is similar layout to Laravel for those that are familiar with Laravel. So config contains lots and lots of YAML files, and then a magical bundles.php, which is essentially service providers in Laravel parlance. I always put my Docker config in the main config folder. I used to have it in resources, but it's configuration, so you can just live in there. Mappings is my database mappings because I use Doctrine. Source obviously is all of our code. So if you remember earlier, I was talking about namespacing your code for each aggregate root, and this is a prime example of it. So we have an account, which is a separate context from a user. It's its own independent thing. It has its own lifecycle. It has its own data. So this is how I structure it. So it's, and I always pluralize it for the most part. I tend to follow the Laravel way, and then my model is singular. And you'll see there's only an account. That's all there is in here. And obviously we've got no vendor files at the moment. So everything is highlighting that everything's missing. But you can see it's an aggregate root, private constructor. We actually have to create it. We have to give it its ID. We have to give it a name. So you can't make it in an invalid way. You can activate it. You can deactivate it. You can destroy it, which actually doesn't do anything. All it does is just raise an event that says, yes, I was destroyed. And then change name. And that's it. You'll see that there's no getters in there at all. The only setter we have is a named function. So, we're trying to use our business terminology here. And that's it. It's self-contained. It self-validates. And then, we then have an API for that. And then when we query it, we use queries. So there's a query handler, which, we write what we want to get. Because we might not want to use the object model at all. But there is an object model specifically for querying. We'll skip over that because what we want to do is just run it. So what I need to do, so there's a couple of things we need to do. The first one is if we swap back to data, because what we want to do in data is, here's one I made earlier. Is that we want to actually expose a database. So the one thing with Docker that can be a little bit annoying is just because we've now added that doesn't mean we can go and start it. What we actually have to do is bring everything down. So we can actually use SPM stop. And if we run it in the project, it will stop data service immediately, or it's just DC down, or Docker hyphen compose down to stop everything. And then we'll just check to make sure, yes, everything's down. And then we'll just use DC up. And then -D is to run it in demonized mode. And what we should have is, right, there we go, GPUG DB accounts. So if we look at our containers, yes, it should be running. And then just to make sure, because, sometimes things do go wrong, we'll just go and check that, yes, it is actually Postgres is running and it's ready to accept connections. Yay. Okay. So we'll then go back to accounts and then switch to the accounts. So we want to, first thing we want to do is make sure we give it a name. So we're using GPUG, if you remember, as our main namespace. And then I like to underscore separate my Docker Compose project names, just so I can then group like the services together versus a web app. I tend to view a web app as being a different thing to a microservice itself. We should really generate up an app secret. And then last thing is to change this one to GPUG. And then there's a couple of special constants for some of my other stuff. So this needs to map to the container name that's in Docker Compose. We also need to change that And I think that's it. This syslog, if you remember, we already have syslog running. So this is actually the name of the syslog container as Docker Compose sees it. So you can just use syslog. It doesn't have to be whatever the hell it is in the list of the containers. Because by default, when you run something, maybe I think I skipped over that. When you run something in Docker, if you don't specify the Compose project name, it will use your current folder name for any of the containers that get started. So you'll see here that everything is prefixed with gpug_data. And that's because we've set in our environment file gpug_data as the Compose project name. But if we hadn't set that, it would be data-service_db-accounts1, _DNS_1. The _1 being the instance name, because you can start multiple instances. So we could run like a second copy of DB accounts, and then we'd have DB accounts 2. That would be really terrible though, because they'd be using the same data source, and we really, really don't want that with Postgres. But you could run like multiple front ends if you so desired. So you could test out like load balancing, whatever. So going back to accounts. So I think that is all of that. Just check my crib sheet. Okay, so in theory, I'm just going to run this actually on the console. Oh, I didn't choose to. I see, made a mistake because I didn't edit the Docker Compose file. So remember me saying about named networks. So we used GPUG. Was it GPUG backend or GPUG network? I can't remember. Cross-reference.
I think it was GPUG backend.
Yeah. So we just have to make sure that we use the same one, and it's external, which is what actually Docker has actually helpfully said. My company was declared external but could not be found, so it actually tells you how to fix it if you really want to. But if we do that, it won't connect to our other stuff, which is not what we want. So let's make sure everything in here. Oh yeah, and I forgot to do that. And then this needs to be changed to GPUG backend. And we actually do get some autocomplete support in PHP Storm for Docker Compose files. And that one as well, GPUG backend. So it's just as well as I edited that. All right, so you'll notice that there's no Nginx or anything configured here. That's because my services run under PHP PM, which is PHP Process Manager. So that's a project for actually running your app in PHP. It's like it is an actual application runner. So your app is bootstrapped and available immediately, always. So you can then usually stick Nginx in front of it because it's, you don't want to be serving static files from PHP. But for the sake of traffic, because it's a CGI process itself, you don't need to do anything special. But if you're running FPM, you do have to route that through Nginx first. So you do have to define an Nginx container if you want to use FPM. But this should now. Ooh. All right. Metadata storage synchronized. And did it work? It seems to have worked. So I can see that PHP PM is bootstrapped. And let's see. This should be very unimpressive because there's no data. Yep. So there we go. It's empty. So it's actually telling us what's available. So we can, and so I already know what some of the routes are. So you can actually access accounts. There's nothing there at present, but it's working, and we are getting responses back. And we can actually look here, and we can see that it's responding back already. And you'll notice that that was on accounts already pre-mapped. Now, where did I put? I think I just closed the window. So if we just go back to here and we go to proxy.gpug. We now have accounts already picked up in our list of containers already rooted, nothing else to do. And it's done entirely through those labels. And then we can see what's going on. We can see what its external ports are and where it's pointing to. And
so Dave,
very nice. Yes.
At this point, you could create an account and it would communicate with the Postgres database that you have in your data services and put that in there.
Mm-hmm.
And that would
Yep.
be over like your command bus, I guess you were saying? Like
Yeah,
I was remembering on the code, like you're raising events about an account being created, right?
Yeah. So if you actually want me to go through that, sure. So the application itself works in the standard way as any pseudo RESTful API. So I structure things in that I have delivery, which then contains like console stuff, and then there might be app, not API, that kind of thing. And then it's versioned. I actually version the code as well. So the roots are versioned in the root because I really hate versioning that's done through headers. So I want to see it in the root so I can replicate issues, just copy and paste URLs. But I also version my code because that's the contract. And then, so to create, there's actually a create controller, and that is the entire content of my controller. It has some kind soul wrote a pseudo form request type bundle for Symfony, because one of the things I really do like about Laravel is form requests. Those things are awesome. They make life so much easier when you're doing request handling, because you can just pre-validate it before it even hits your controller action, which is just fantastic. I don't know why Symfony doesn't have it, because Symfony Forms is just horrible. And then, so all I do is I get the command bus, which is pre-mapped through this API controller, base controller, and then dispatch a create account. And that is it's a plain old PHP object that inherits from my library, because there's a magic rule which routes anything that's abstract command to a specific bus in the messenger configuration. So under the hood, this is running on Symfony Messenger, just kind of beyond the scope really of what I wanted to talk about. I didn't intend to get into PHP code, to be honest. But you can see all it does is it just contains the ID and the name. And then for that, there is create accounts command handler that takes the repository and it creates the account. So it uses the create, so that will then raise that event, and then it just calls store. Well, that's it.
Yeah, I was trying to kind of figure out just kind of like piecing all the pieces together, like with the microservices, and so the request comes in through the accounts create endpoint, right? And then so we create that, and then we raise the so that command gets pushed out onto your command bus. Now, when that gets pushed out on the command bus, is that something that gets processed through like RabbitMQ? Like I remember you had like a Rabbit.
No.
Oh, okay.
So the commands are done synchronously. So if I open up the messenger config, wow, getting really into the internals of Symfony.
Yeah, sorry. Maybe this is. I think if it's not like within the Docker container stuff, I think we can probably gloss over it. I was just kind of wondering at what point does it go from like is the account service here somehow configured to talk to that Postgres database that lives in the data service that's exposing that port?
We actually did that in the .env.
Did I miss that? Oh, right there.
So
okay,
there's a database URL, and we're saying we're connected to Postgres. The GPUG and our password is secret, and it's at DB accounts.
Okay.
Which is the container name. Oops, wrong shortcut. Which is the container name here.
There it is. Okay. All right. Thank you.
In Docker Compose, these container names become automatic. They resolve automatically between the containers, so you don't have to do any other DNS work at all within your container stack. And if you bind to the same network segment, which is why we set up this named network, then across Docker Compose files, they can talk to each other and everything automatically works and life is good.
That sounds like life is good. All right, thank you.
Yeah. Okay, so any other questions before I go on?
None have come in since I started talking. So no.
Okay. All right. Time check. Oh, getting late. All right. So, one last thing. So, what we can then do is we'll just run SPM status. What we can see. Oh, hello. Apologies if I just cut out. I do have Bluetooth issues with my Mac because Bluetooth on Mac OS sucks.
You're still here.
What we'll see is that, sorry, not DB accounts, GPUG services. So here we go. It's up. It's running on accounts.gpug.dev. And then just ignore mutagen for now. So I definitely don't have time to talk about that. And you'll see that it's all registered. But what we've got now is an overview of everything related to our GPUG project, not just the data service. So if we were to go to the GPUG data services and we run Docker Compose PS, which is to get the process list, all we get is what is defined in that Docker Compose file for that service that's been started. We've got no idea if anything else is running. Now, Docker for Mac, and I don't know about any of the other versions, finally in the more recent versions, does give you an overview of running Docker Compose files, but still doesn't give you something equivalent of like this, which is already extracted out like the ports. So all these ports are what you use from your local machine to talk to this thing. So like if we wanted to connect to the Postgres instance, we could do that by accessing port 54321 if we really wanted to. Which becomes even more important when you've got multiple databases, because it's really easy to get conflicts. That's one of those places where it makes sense to centralize your databases. We have, I think it's 6 Postgres instances at Melos. I think that's right. So without having somewhere centrally, like which is the next available port, because no one reads the documentation, even if it is in Confluence. Whereas if you just go to the Docker Compose and data services, what was the last entry? Well, take whatever port that is, add one to it. That's its new port. Job done. And then if you just run SPM status, it's all there for you. It's all unambiguous. So the last few minutes, there's a lot more functionality within the project manager. But one of the things it does allow you to do, and I touched on it earlier, is that you can actually set that this service depends on something else. So clearly, the account service depends on the data service. Now, if you start it, yes, you can start it up, but it won't work. Actually, it'll fall over because there'll be no database for it to connect to, and we will all be sad. But so what we can do is we can actually, if I remember how to do this, there's the one part which I haven't actually. There we go. SPM config. So these are the various things which we can actually tweak via the CLI. So it does also support autocomplete. Thank you, Symfony components. We just want to do dependency add. We want to modify accounts, and the service name is data service. Should probably actually have an autocomplete list there as well, I think. But you can add multiple services to separate them with a comma, and then that's it. That's it. It's just made that change. But now, if we do SPM stop in data, I don't know if you'll actually click. Oh yeah, there we go. before stopping data service. So you see, it's still attempting to stop the data service. Now that's really, I don't know of any other library. Someone might have one. I don't know. But this means that now, if we want to go SPM start the account service, it'll say, yes, it's got dependencies. Yes, we want to start them. So it will start them, and it will resolve multiple layers so that everything should, in theory, start up correctly. Assuming that everything is actually working. And there you go. You see that everything is actually started. Amongst many other things. So you can use this to edit some of the configuration. And if you just want to edit the actual raw config for the current project, you can just run spm edit. And we will just open a new window. And you'll see that it's in GPUG and in the .spm projects folder. It's just a project.yaml, and it's just really straightforward. This is the configuration, and you'll see that the account service has a dependency on data service. And that's it. So you can change it. So if you change the name of the container, for example, that's the primary container, you can just update it in here and save it. This is all managed by Git, so it automatically creates a Git repo. So you can then set a remote. So you can do SPM push to push changes to it, SPM pull to pull changes down, and it works really nicely. You can get an overview of the services. Of course, this is the wrong terminal. Hang on, switch to this one, which has actually got the. So it'll actually tell you if you've got the thing installed and whether it's running for the different services and libraries and things like that. So it can make life a lot easier. But yeah.
Yeah, this is an immensely impressive project. I'm actually kind of dumbfounded to see how broad it is and how much you've been able to link everything together. It's wild. It's pretty incredible.
It's just under the hood. Really, there's no real magic to it. It's just basic text matching of Docker, standard Docker output from the Docker commands.
It's wild.
You can run every command with -vvv and actually see what it is doing under the hood. So
yeah, Dave, this is incredible. Honestly,
I'm just catching up on part of the conversation with that was running in the chat about the notion of decorators. That actually can be done really, really easily through Composer. Write a Composer package, and then you can write your setup as a Laravel service provider, as a Symfony bundle. You can use the pre-install, post-install hooks and do whatever you want in there specifically for your use case. It's already available in the tools that we already use. That would be the absolute best way of doing it, if you ask me.
Cool. One of the things that I thought I really appreciated you saying was microservices. What I took from it was that microservices aren't the place you start, and then start with the monolith and then grow it out from there. Separate your services as you go. And it's kind of like more of an organic process. If I understood that correctly, I really think that was really nice to hear. Okay, Dave, back to you, man. I was really hoping that you could answer, because I was watching your screen and I was looking at the top bar and I was looking for the little Docker for Mac guy, and I'm curious if you're running Docker for Mac at all.
We will get to that in the second part. Now, all these microservices is great when everything works, but what happens when it doesn't? How the hell can we debug? Because obviously now we have multiple things that could be going wrong, and multiple ways to find information about why it is going wrong. So this is part of the reason why I added the syslog service into my data service, so there is centralized logging. And if we actually switch back to the data service, in the bin folder, like any good developer, I'm fairly lazy. So what I actually wrote was a handy little bash script that will query the container for the log files that have been generated by anything that's been configured to run syslog. So we can just go and, grab the information and, you just, instead of using -l, specify the file, and we can see that we've got the output from the application. And then this also does do -f. Essentially, it's just tail, but running in the Docker container. So we can then be trailing through the content, because it's trying to figure out where stuff is a bit nasty, and these paths aren't great. I may update this a little bit just to make this a bit more interactive, so that it gives the list and it's like, which one do you want? I think that'll be more useful. So that's the first step. If you've got Kibana installed, then you can go on searching Kibana. I'm not a huge fan of that. That needs a lot of setup. I did actually, I was working with a DevOps friend of mine to get the logging service up and running. The one thing we did run into was that it's really difficult to configure up those nice dashboards in Kibana before there's any data. It really doesn't like doing that. So you really need someone who knows Kibana to actually go there and configure it. So I've not dealt too far into that. I don't know if there is a way, but like I said earlier, I'm not a DevOps person. So at that point, it's like, I want it to be somebody else's problem, especially in production. But for dev, for just getting the logs and doing basic searches, it works reasonably well. Otherwise, this way, from the command line, you don't even need a web browser. Then within each service, Docker does give us logs. So that is DC logs without any information, gives you all the output from all the containers that are running, which is not necessarily great. But if we then just give it a specific container name, then we get just that output, and then you can also tail that as well, so you can get that output. Now, the problem with these though is that if you've had it running for a while, then when you actually first do this, it actually gives you everything from when it started. So you'll just get reams and reams and reams and reams of output, which is not necessarily useful. But you can obviously pipe through grep and all the rest of it. Obviously, if you're running a PHP application and it's falling over, provided the container hasn't stopped, then you can use your debug bar, your or Symfony debug bar, or whatever it happens to be that you've got on those, or just the good old dump and die, or you can configure up xdebug. You can do that through, it's slightly more convoluted to get that working. I've never got it to work easily every time. It's one of those things where you have to start to fiddle with it a little bit, but you can get it to work. I think I'd set it up in the app skeleton. I can't remember though. But it is possible to do that as well. The logs from from Docker, I actually did alias, so you can actually get the logs, which is usually services logs, service log, sorry. So we can then run that, and all it's doing is grabbing the Docker output. But you can use our friendly name, as opposed to having to remember what the container name is. So it will just use whatever is pre-configured, so you can get the log information. So if you can't figure out though what the hell is going wrong, and you're just banging your head against a wall, then Docker fortunately now does have the solution to all your problems, which is Docker system prune -a --volumes, which will kill all running containers and then delete them, and all the images, and all the networks, and all the volumes, So it's completely wiped clean. There will be nothing left over. So, if everything's all gone, you just have no idea what's going wrong. You can't figure it out, and you just want a clean build environment. You can do that, and hopefully, from there, start up your services one by one until you find the problem. Sometimes it can be a little bit of digging through a haystack. One of the things which I have implemented, but again, this is where it comes down to Kibana, is really difficult to configure sometimes. In my code, I have a request helper that generates up a request ID that is then prefixed into the logs that are generated. So that request ID is then forwarded across every running API call. So let's say you've got your main entry point applications. It could be Laravel, it's Symfony, or it's Python, or whatever it happens to be. You create a request ID, then for every API call, you embed that request ID in the headers, and it will make sure it's written into the log files. So the idea is that once it's in Kibana, you can write a query which will grab all the logs from all the containers and present them all together in one stream of the entire request. But I haven't managed to get that. There are apparently some logging services which can do that, but I've not tried them, so I'm not sure.
Dave,
yep.
We have a question from Hossein again. Just asking if you've ever taken a look at New Relic.
Yes, I have. I used to use New Relic. I was even featured in a case study for New Relic.
Really?
Yes, when I was at voices.com.
Well, now.
Yeah, and that's when I learned that I can't stand seeing myself or listening to myself. Yes. I'm quite familiar with New Relic. Not up until a few years ago. I stopped using them because they were really expensive. Like they got to be incredibly expensive for what they were offering. And the last service I used actually was Tideways, which was started by Benjamin Eberle, and I can't remember the other guy, which works really well and was a lot cheaper. But similar thing, application monitoring for specifically PHP, Laravel, Symfony, with traces and profiling and all that kind of jazz. So that's another way you can, as long as the app runs enough, you can use those to collect telemetry and exceptions. The one thing with Docker containers though is that, like especially in this case, with running ppm, is that if the error is bad enough that ppm itself stops, you're not going to get any errors at all out of it. And in fact, at that point, because the container's stopped, you're not going to get any errors at all. Like that's it, because the container's dead. And when the container's dead, it's gone. Which is why we use volumes to persist data. If you wouldn't need to keep data across container starts, that's why all the database services had those named volumes in the data service. Which is nice because it means that in a Docker environment, everything is essentially immutable. It can sometimes feel like you make no progress with debugging, and it ends up almost certainly being, oh, I didn't rebuild the container, or oh, the container service stopped. So that's when using SVM status is useful, because it's like what is actually running on what port. But like with anything, it can sometimes be trial and error. But assuming that you've got suitable backups and everything is your system is working well, just being able to go Docker system prune the lot, which I do periodically. I must admit. Less so at the moment, just because of the data set I have to work with. Restoring 200 gigabytes of database information is not a task I like doing, even if it is automated. That's like the go-to, which is nice because there aren't very many other systems where you can just nuke everything and go, okay, fine, let's start again. All right. So the last thing I wanted to touch on is the thing that if anyone's ever worked with Docker and Mac loves to hate, which is Docker for Mac itself. Because let's not kid ourselves, it's not great. Now you can point the finger wherever you like, at Apple, at Docker, at the community at large. But the fundamental issue is that there are problems with running Docker for Mac, even with the latest version. Now, admittedly, I have not used the most recent version of Docker for Mac, so I can't specifically from my own experience state whether things are better with the changes they've made. But there are two primary issues that affect Docker for Mac. The first, which is the most common, is OS X FS crashes, taking everything with it. OS X FS is the old process that translates your Mac OS file system into Docker, because Docker for Mac actually runs a small Linux kernel in a VPN Kit environment. So it uses the native Mac OS virtualization environment. And so OS X FS forwards the various file system events from Mac OS into Docker so that everything appears to be in sync and is responding. So if you make a file, it appears. The problem is that either there's too many events, so it falls over, or that the OS X FS is just badly written. It's maybe possible. Or a combination of all things. The underlying HyperKit might have issues, which is probably highly likely since it doesn't seem to be getting any development time at the moment. But either way, it means that if you do anything involving heavy amounts of file I/O, you will invariably crash Docker, which appears first as lag into your container and into any Docker process. So you've seen that I've been doing like DCPS quite frequently, and it comes back pretty quickly. On Docker for Mac, when it starts to have issues with the OS X FS process, that starts to lag. So you run it, and then you get output, and then you run it, and then 15 seconds later it gives you output. And if it gets that long, you need to kill Docker and restart it because it's going to crash. And when it crashes, the whole Docker engine crashes and becomes completely unresponsive. Similarly, there's another process called Vpn Kit, so com.docker.vpn kit, which does the same thing as OS X FS, but for networking. And it too can fall over and crash and take the whole of Docker with it. This is great. This is lovely. And that one happens when you punch a bunch of network traffic from your local machine into your Docker container. It doesn't affect inter-Docker processes. It's specifically from your host machine into your containers. That one can take quite a bit longer to manifest, but what you can see is if you open Activity Monitor and start running it and filter down to com.docker, you'll start to see the memory usage start spiraling up. By default, they're around like 10, 20, 30 meg, and then it'll just go to 100, 300, 600 meg. And if it gets anything more than that, yeah, it just falls over. Now, in the latest version of Docker for Mac, they replaced OS X FS with a new, in air quotes, mounting system, which is supposed to improve things, but the anecdotal evidence is it doesn't make any difference whatsoever. So this is problematic because the normal way that pretty much everyone first uses Docker is they mount their local folders to the container directly. So what do we mean by that? Well, we'll just clean this up and we'll open Docker Compose. There's well, you can't even see it here because I don't use it specifically for this. But what you can do is define a volumes label group, and then you can say you want to mount the local file system to I think it's like that, to a point in the container. And this will mount in this case, dot, which is relative to wherever Docker Compose happens to be. So it will mount the root of this project. So all of this stuff to a /app. And this is what everyone starts out doing, because that's what every guide ever always does. And you'll do this for like node modules and vendor, or maybe even databases. So this is fine on Linux. This doesn't matter on Linux. You can do that. It works quite well. But on Docker for Mac, you're now generating an enormous amount of file I/O that has to be managed by these file processors, and that is what causes it to crash. And for me, when I was at Harness, which was the commercial real estate company I was working with a year or so ago, I was the one which was in charge of the Docker dev environment. So that meant I had to do all the debugging, and I had to step through all of the setup processes, make sure everything was working well, which meant that I was tearing down and rebuilding my environment 3 or 4 times a day, which should be fine. But that was tearing down and rebuilding 30 to 40 gigabytes of data every single time I did that. And I had to always ignore the caches because I had to rebuild from scratch. So I was having Docker crashes every other day, which, at that point, and you've got no idea when it's going to happen. Sometimes it can happen almost immediately. Other times it will go for like 24 hours and then it stops working. But it always stops working at the most inopportune moment and then takes forever to lag out and actually die. Sometimes it doesn't even actually die. You actually have to kill -9 it. So it was bad enough that I actually had a bash alias to specifically kill Docker for Mac when it would crash. So the primary solution, though, to get around this is to reduce that file I/O. And the best way of doing that is what you can see here is there are no volume mounts at all. So instead of using a volume mount, you create what I refer to as a compiled container. And that is that the container's image has all the files that it needs to run already built into it, defined in the Docker file. So in my Docker file, you see that I'm pulling in my own image. So I've got PHP PM already set up. And then I install a couple of additional extras from Alpine, because I run Alpine Linux. And I don't use the official PHP image because I don't see why it should have to compile from source when it's already there in Alpine. So this is usually faster and smaller. Then I copy my composer files and my environment files, and I run the composer install in the container. So all of my vendor files will be written into the container. And then I copy everything from my local into the container as well. And that's it. So all of my files, all of the source files, everything is already available in the container. There's nothing else to do. You can actually save that image and then run it in production if you wanted to. It's ready to go. You probably wouldn't want to with the dev setup, but it would be ready to go. Now, the downside to this, obviously, is if you make a change in any of these files, like say, for example, we want to change a root or whatever, now we have to stop everything, rebuild it, and then bring it back up again. Fortunately, there's a group of nice people realized that this was not really great, and they created Docker Sync. So the first one was Docker Sync IO, which works reasonably well. However, it still has that problem with the mount. It's just deferred. It still does a mount and then rsyncs the files into your container. So you still end up actually with the fundamental problem. And it was a while later, so I tried that and then I still had crashes. I then found mutagen.io, which doesn't do any mounting at all. It actually installs a client service into the container, and then it does direct syncs using the Docker's copy API. So I Don't ask me why. I have no idea why this works more stably than using a volume mount. I have no clue. It's a mystery to me. But that works much more reliably. And you can actually set up mutagen to sync specific files. You can do one-way sync, two-way sync. So you can actually use with mutagen, do all of your dependencies in the container and then copy the changes back to your local if you wanted to do it that way. But then, of course, you don't have the vendor files locally. So what I do is manage all my vendor files locally and then have a one-way sync to the container. And then occasionally I will do a composer install in the container if I need to overwrite anything. Now that works actually really quite well, and it works reliably. And there's not a lot involved in that. I started using mutagen back, I think it was version 0.6. They've added additional features since then. But one of the things it didn't have was projects or way of configuring it to pre-build tasks or whatever. So I wrote a little helper which is called Syncit. It's on my Somnambulist Tech GitHub. You can brew install it, and it just uses a simple YAML file to configure the mutagen tasks. So you can then set up the and like this is the account skeleton. It's already predefined. So actually manage that. So we can actually we can do Syncit status. We'll see that nothing's running. But I've got tasks for the source files, for the migrations, which is two-way. So obviously the migration is built in the container and then copied back. The vendor files, and then our composer. And that works really, really well. In fact, after I switched everyone over to this, the number of issues we had dropped quite a lot because it's kind of being taken care of now. And one of the guys I work with, actually, once I forced him into using my tool set, half the issues he was having with his environment went away, which is very nice. Because there were so many, like, there'll be problems of people wouldn't clear out a cache, or that file syncing of the local mounts wouldn't work properly, or it would just fall over. And then this just alleviated it a lot. And actually, SPM and Syncit were more developed out of Melos because of all these teething problems from Harness that I had, and I just didn't want to go through it again. Of course, though, the very last thing, which is what Colin, you pointed out earlier, there's no Docker for Mac on my computer. That's because I don't use it. As I've already mentioned, one of the ways I solve problems is by throwing money at it. So I bought myself a dedicated Docker host. I have a literally it's a Lenovo M720p Tiny, so the really small form factor. It's about the size of a Mac. It's actually smaller than a Mac Mini. It's sat in my rack because I'm spoiled, and this year I bought myself a 12U rack with all of my networking gear. And I run all of my Docker stuff on that. And that is entirely configured through one single environment variable. If you set Docker host and point it, in this case, it's unsecure because it's in my local network. So whatever, I don't care. Everything just works. You've been seeing it. Everything I've done has been running on a remote Docker host. And none of it has been running on my local Mac. And all the commands are exactly the same, no differences. And mutagen will work with that without any issues whatsoever, whereas Docker Sync IO won't work with a remote Docker host because it still tries to do the local folder mount into a container, which then does the rsyncing. So yeah, that's how I solved it. And actually, the guy I work with at Melos, he threw in the towel as well. He was so sick of Docker for Mac that he did exactly the same thing. He uses, was it Ubuntu or Fedora? No, it's Fedora, I think he's running for his. I use VMware Photon OS, which was, that's VMware's container OS, which is supposed to be used with ESXi. But it can run on bare metal. So I use that because it's really tiny. It's like a gig. And it contains like just everything that you need. Some updates. So you can see here that is running. It's all the containerd stuff that should be Postgres. Yeah, there's Postgres is running there, and syslog and DNS mask. And it was game changing for me doing that, switching to a Docker host. If money is no object and you can, then it's absolutely the best thing you can do is run Docker on Linux.
I think, yeah. So this is something that we've been talking about at Vehicle, actually, is getting just a beefy Linux computer and just sticking it in with all of our Mac Minis and having people build their Docker stuff off of that. So, I mean, if it's just as simple as saying Docker host, that's pretty remarkable.
Yeah. So in that situation, what you have to be careful of, though, is that when using all those names, so we named everything GPUG something, like GPUG data, GPUG services, which means that the containers are always compiled with that name. So if I do Docker container list, you'll see that there's GPUG data DB accounts, and there's container list, which is the current running instance. But the image list as well is also the same. It uses the same names. What you may find is that you then get collisions if you have multiple users trying to run the same project on the same host. So I'm not quite sure what you would do in that instance.
The way that, I don't know, it might not be an actual problem the way that we work at Vehicle, where we have basically teams connect to a single computer, and then we all program on that one computer. So if it's like one computer to one project, I'm not sure if we get many name collisions. It seems like it might be useful.
So I think so long as you chose appropriate names, and since it's just configured through a .env anyway. So all you have to do is just define compose project name somewhere, either in a .env file, which Docker will use, or you can pass it in on the command line, or define it as an export. You can just whatever it is, export compose. You can just do it like that for the shell. So you can always change it. It's just that .envs tend to be, at least in Symfony land, the .env is committed to Git. So there is no example. If you want to override it, you use .env.local. Whereas I know in Laravel it's .env.example by default, and you copy that to .env. But that's because the way Symfony works, it's layered overrides. So you've got like .env and then .env.test dev prod or whatever else your environment name is, and then those are all committed to Git. And then if you want to override anything in any of them, use .local.
That's cool.
Yeah, slightly different way of working, but yeah. So my little Docker host is it's a Core i5 six core, which I stuck 32 gig of RAM in.
Fantastic.
Works great. The one thing I did have a problem with those, I ran out of disk space at first. I only had a 512 gig M2 SSD, and then I filled it. I don't know if any of you have ever seen what happens to a Linux system when you fill the disk. It wasn't pretty.
Yeah.
So it's now got a 2 terabyte SSD. And what I'm thinking of doing is next year is replacing it with a Supermicro embedded EPIC, and then having a RAID array.
I want to thank everybody for coming out. And this was your October GPUG. Thanks, guys. And thank you, Dave, also, actually.
Yay, Dave.
Yeah.
Good job.
That was awesome. That was really great.